So here we'll be seeing a sixth problem with respect to series parallel. Now this one problem has different switching conditions of resistance. So we have two switches. We'll see four different cases for the problem. So I'm Mohan PS, working as assistant professor in Department of EEE SJBIT. So to find the total resistance across A B for different switching cases, so we have four cases. Case 1, S1 and S2 are closed. S1 S2 are open. Case 3, S1 closed, S2 open. Case 4, the opposite, S1 open and S2 close. So let's see how do we solve this to find the total R equivalent across A and B. So let's take the first case. Now, so when both are closed, so the circuit is as shown below here. Now to analyze this, pause the video. You've seen already we have solved or seen the other problems. So I want you to pause the video and analyze, solve. Okay, don't take more than probably 3 minutes to crack this problem. If you're taking more than 3 minutes, so what you can do, you can resume back to this video. So let's see. Now, so here, this is actually a wire. So I have also rewritten in this way in this circuit diagram, right? So let's see further. Now what I have done here is at this node or junction, I have 100 ohms connected and 25 ohms connected. They together are connected at this junction. So this is it's something like this. I have 100 and 25 which are connected. So from this point, it's also connected back to 20 ohm, right? So I can rewrite in this way also. So 100 ohm is still connected to this point and 25 ohm is still connected to this point. Thus it is, these two circuits are electrically correct. So let's analyze the small animation here. So I can move this 100 ohms along this wire. I hope you have understood. I can move this 100 ohms along this wire, and I think now you have a clear vision in analyzing for series and parallel. So we're just trying to rewrite the circuit, and I want you to understand that this, between these two nodes 20 and 100 are parallel. So I think you have seen the previous videos to analyze how and when can we call two or more elements as parallel. Now I can also say 25 ohms is also in parallel. So 25 ohms is connected at this junction. Now what is this? This is actually a switch which is having zero resistance. So I can shift this wire at this point. So let's see that in the next animation. So you can see here. So you can see here the difference between these two circuits. I have shifted this junction at this point. So both are at the equipotential because that's the wire which is having zero resistance. Thus I shifted this point or this junction to the above point. Okay, so thus I can say that 25 ohms, 10 ohms, 25, 100 and 20 all are connected at this one junction. Similarly 20 ohms, 100 ohm and 25 ohms other end are connected at this junction. I can say all three are parallel. I can further rewrite in this syntax, and now all these three are parallel. So in generally, how do you do the conventional way? So 25 into 100 divided by 25 plus 100, you get one answer. Let me call that as A, and then 20 is in parallel, so 20 into A, the result, divided by 20 plus A, you get your solution. Or what we have learned, 25 inverse plus 100 inverse plus 20 inverse, the whole inverse. So in general, this is what a student generally miss. So any number of elements in parallel, you can use this in one formula. So you can see by conventional method, you'll have n minus 1 steps. If you have 3, you'll have 2 steps. If you have 4 elements in parallel, you'll have n minus 1, that is 3 steps. Whereas by this method, you have one single step for the solution. So by solving this, the answer is 10. So 4, 10 and 6, all these three are in series, which gives us 20 ohm. So let's do case 2. So we'll be solving for case 2 now. That is S1 and S2 are open. So S1 and S2 are open because we can remove these two switches. It appears now. It's simple that whatever current enters goes through 4, 20, 100, 25 and 6. Thus we can say all three are in series. I mean all the resistance are in series, and the answer is 155 ohms. So series is like how people are standing in queue, one after another, right? So let's see the third one. S1 is closed and S2 is opened, right? So S2 is open, as you can see, and S1 is being closed. Now the same way, at this junction we have 125 which is connected to this point. So I will not repeat this, that we have already done analyzing for case 1. So from here I will take it further. So I have just brought this down here just to explain a concept. Here, as the current enters, when we connect a battery at A and B, not debating on its polarity, the current enters through 4, right? It has 2 paths, or you can say we have 1, 2, 3 paths. The current enters through this first branch, that is the second branch and third branch, enters through first branch, goes through 25, goes through 6, and comes out to the battery. Whereas if the current enters through second branch, you can see these two are same actually, right? So I'll call this also a second branch. The current cannot come out from the same junction. I repeat, the current cannot come out from the same junction. So this is actually a closed loop. The current will neither enter from this, neither will come out from this. So thus we can neglect this loop and rewrite this circuit diagram, which is reduced now, and thus we can say that 4, 25 and 6, all these three are in series, and the answer is 35 ohms. Now, last but not the least, S1 is open and S2 is closed. So S1 is open, as you can see it's open here, and S2 is being closed. How do we analyze this? Now let us take a few examples here to understand, and then we'll move on to this. So let us concentrate here. Now what is the answer for this? So we'll always try to find what is the R equivalent for A and B now here. So across A and B I would say the answer is 24. Now if I shift my point B from this point, if I shift to this new point, so what is my A and B? Is it still 24 or something else? So across A and B, the current, if I connect a battery, the current flows through only 4 ohms. It is not traveling through 20. Thus I would say my answer is 4 ohms. Now if I shift my point A from here to here, so what is my R equivalent now? Do you think it is still 4 or something else? So how we have to analyze that? If I connect a battery, do not debate about the polarity of the battery. So the current flows through 20 ohm and not through 4. Thus my answer is not 4 but 20 ohms. Now, so what is this? What are we doing here? So this is just a wire, an ideal wire having a resistance of 0 ohm. So I can say that I am actually short circuiting this 4 ohms. So this is a common junction for the wire and 4 ohm, a common node, or a junction for 4 and R. So this is just a resistance of having 0 ohms. So 4 into 0 by 4 plus 0, we get 0 ohms. That means the effective value of this is simply 0 ohms. That means this is my practical circuit. Now what is the R equivalent for this? So the R equivalent for this, even though I have 4 ohm, it's being neglected because the current chooses the least resistance path. So none of the current will actually flow through 4 ohms. It will in fact bypass 4 ohms and travel through 20 ohms. So my R equivalent is now only 20 ohms. Now, so what is the answer? You think it's still 20? Let us say point C. So what is my R equivalent for A and B? So I have given one more point C, but I have connected a battery across A and B, and what is the R equivalent? So the R equivalent is still same, that is 20 ohm, because current flows through this point, flows through the least resistance path. The circuit is open here, so it flows through 20 and thus completing its path. So the answer is still 20 ohms. Now, so what is this difference? What is the answer now? If I connect a battery, where does it flow? It flows through the least resistance path. So this is actually R is equal to 0 ohms. So we can say 4 and 20 are in series, that is 24 ohms. And we have connected a 0 ohm resistance in parallel. So 24 into 0 divided by 24 plus 0, we get 0 ohms. So the total equivalent resistance is actually 0 ohms. Not 24, not 4 or not 20, it is 0 ohms. So I hope you have understood that when it is 0, when you have to neglect the resistance, when you have to include the resistance. Okay, so resistance can be included, can be excluded. It all depends on where are the two terminals. Now, so what you have to do here. So let me redraw the circuit this. Now, I'll say this is my equivalent circuit. So let's see the figure here. So what I've done here is this is just a wire. So I just shifted this terminal along this junction. So I cannot go beyond 6, neither I can go beyond this junction. So that is what I have drawn here. So this is just a loop again. This is just a closed loop. The current, as it enters any direction, either from right or through 6 ohms, it cannot enter and leave the same junction. Okay, so thus it goes through 6 ohm. So thus we have to neglect this. This is the circuit, reduced circuit diagram. Thus 4, 20 and 6, all three are in series, and the answer is 30 ohms. So I hope you have understood the different conditions, based on different conditions or cases, how the value of resistance changes when you have to neglect the resistance, when you have to include the resistance. So please subscribe the channel to enhance your knowledge further.